faster. All right. So the other option is another thing you'll see commonly is what we call testing claims about values. And so I'm going to show you some examples of this, and then we'll start to kind of figure out how to actually do it. But here's an example. So I need to update these slides because some of my numbers now are getting kind of old. But so Honda claims that a 2018 Honda Accord Hybrid achieves an average of 45 miles per gallon overall. So let's say that your job is to test that claim. So they're telling me something is true about the mean, and my job is to decide whether or not I should believe them. That seems like a reasonable thing to want to try to do, right? Okay, so how would you do it? If you were like a scientist or a journalist or something, how would you do it? You'd have to drive a bunch, right? So you'd have to go out and, hopefully you would do some random selection, so you'd probably randomly select, in vehicles of that make and model that year, right? And then you'd probably, my guess is, drive them around, a while, who knows, just drive around like it's 45 overall, so you probably try to get a few hundred miles in all conditions, all types of driving, freeway, in town, that kind of stuff. And then at the end, what would you do? So, because their claim is a claim about the what? Miles per gallon, and it's a claim about the average miles per gallon. So if they're making a claim about the average miles per gallon, then we should probably calculate what? Yeah. Right. So we would take our gas and the miles we drove, and we would calculate, an average, right? So we would come up with a sample mean MPG at the end of our, experiment. Okay. All right. Well, now the question is, what would that sample mean have to be for us to believe them or not believe them? See, that's the thing, because let's say hypothetically. Okay. Let's say hypothetically, maybe you are able to get your hands on, depending on who you are, but let's say maybe you were able to get your hands on 20 Honda Accords. Okay, that's a lot of vehicles. So let's say hypothetically you were able to get your hands on 20 vehicles. You drove them all around. You calculated their average. Maybe you drove each of them 200 miles or something, and then you calculate their average miles per gallon. And let's say that the sample mean that you got was 44.6. Okay, so their claim is 45. My 20 cars got 44.6. You believe them? Okay, fair enough. You say, okay, my sample is a little lower than yours, but, seems reasonable. What if you did the experiment and your sample mean was like 43.9 miles per gallon? You believe them? Some say yes, some say no. So I drove 20 vehicles, 200 miles each. My 20 vehicles averaged 43.9. They say the truth is 45. That's almost 44. It's getting low. Do you believe them or not? Some people say no. How many of you guys say, whatever, probably. It could be still. Could it be true still? They could still be telling the truth. Now, eventually, though, I think we could all agree that if you got to a certain point, like let's say our X bar was like 38.2, right? Then at some point, we could probably all agree that, okay, something is fishy here. This is weird, right? Because how is it possible that the claim is 45 and yet I drove 20 vehicles, 200 miles each, and I ended up with something way lower than that? Okay. And so eventually, somewhere in here, there should be a cutoff. And what we have to decide is, if you're going to go out and you're going to test this claim, we have to decide, well, where is that cutoff? Because we have to be willing to accept some deviation from the claim, because it's just random sampling, and we know there's margins of error. Like, this is our guess, but there's probably a margin of error associated with this. But eventually, it's going to get to the point where we say, I don't think so. I don't think this claim is true. Okay, and so we have to decide where to make that cutoff. And ideally, it wouldn't be subjective. It wouldn't just be us like picking a number and being like, that number sounds cool, so I'm going to go with that. Okay. So this, when you're testing claims, we call this hypothesis testing in statistics. So a hypothesis test consists of two things. Okay. So there's always a claim that's being made, and we call this the null hypothesis. Okay, and the null hypothesis we denote with an H with like a little zero underneath it, like a subscript of 0. So it's the null hypothesis is H0 or H naught, and there's always some claim being made. So like if we're talking about means, the claim is that the true mean is equal to some value, and then this mu 0 is going to be like the actual number that's being claimed. So we're going to set a couple of these up so it makes more sense. But that mu 0 it'll be an actual number. So like in our case, it'd be 45, like for the Honda example. So the claim is that the true mean is whatever someone's claiming it to be. Okay? Now, typically though, we're going to go in with some sort of alternative hypothesis, okay, and this can be denoted with an HA. Sometimes you'll also see it denoted with like H1, and it kind of depends on the textbook, but it'll go either way. I think I tend to write HA a lot, but I also sometimes write that, but it means the same thing. I need to be more consistent because I can't remember what my quizzes have on versus what the book says. It doesn't matter. It's one or the other. Okay. So now the thing is that the alternative can go a couple ways, because like in the case of the miles per gallon example, if they're not telling the truth, you probably really only care about one alternative. Because what if they say it's 45 miles per gallon and their cars are actually getting like 47 miles per gallon? Does anybody actually care about that? Not really, except for maybe Honda, because then they can make a better claim. But if you're the person testing it, it's like, who cares? All you really care about is if what? Yeah, did you actually get to 45? Because if it's less than that, you're in trouble, right? So alternatives could take on, like your alternative may be a less than alternative. Sometimes you might be interested in a greater than alternative, but sometimes you might not actually care. You might actually just have a general not equal to alternative. And so when you're doing a hypothesis test, you have to pick one alternative. And it's typically going to be whichever one you actually care about. So sometimes you might care either way. You know, like if you're Honda, you actually probably care both ways. Because if the truth is less than 45, you need to adjust your claims. And if the truth is more than 45, then you can also adjust your claims the other way. They would care both ways. The EPA only cares one way, probably. Okay. All right. So I'll show you one of these. We can do one of these for the Honda example. So the way a formal hypothesis test looks is you say H0 colon, and then you say the claim is that the mean is 45. That's the claim. And we kind of just talked about this, and we'd say then our alternative, though, is we care about whether the mean is actually less than 45. Okay. So this would be a formal hypothesis statement. This is how you would structure the test. And the way a hypothesis test is that we typically work under the assumption that the claim is true until we can be convinced otherwise. Okay. So we work under the assumption that they're telling the truth until we see enough evidence to suggest to us that actually maybe the claim's not true. But we'll take their word for it up until that point. This is the framework of a hypothesis test. Okay? So far, so good? And how you pick your alternative is just based on the scenario. It'll change based on what you care about. Right. Now, in this case, we're talking about means, right? Averages, means. But from Module 8, we know that we can do statistics with averages, but we can also do statistics with proportions. Okay, so we're going to look at both. We're going to do a hypothesis about both. So for means, if you're doing means or averages, then the null hypothesis, like we said, is going to be, everything's going to be in terms of mu. You know, and your alternatives could be one of 3 alternatives. So those are your options, but notice it's all in terms of mu. If you're doing proportions or percentages, you know, it looks exactly the same. It's just everything is going to be changed into p's, right? So your null hypothesis will be that the true proportion is some value, and you'd have to pick one of 3 alternatives. Either you might care if it's less than, you might care if it's greater than, or you might just be interested in knowing in general whether or not it's not equal to. But again, for these, right, you just pick one on the alternatives. Okay? But just like in confidence intervals, it's very important that up front you're very aware of which statistic or which parameter you're doing tests about. It matters a lot, right? Because if it's a proportion, like in confidence intervals, if it's a proportion or a mean, the formula completely changes. So it matters a lot that you understand whether you're dealing with averages or percentages. But the actual tests themselves, the formal statement looks very similar. So we'll go through a couple more. We'll just set up a couple more of these. And then we're going to talk a little bit more about how you actually do it. Okay. All right. So here's another example. This is why I need to update them because we don't even offer this class anymore. But Math 84 used to be a class that we taught at CBC. And so Math 84 had a pass rate of 65%. However, we made changes to the structure of the course, and the department would like to know if it's changed the pass rates. Okay. So we can set this up as a formal hypothesis test. So remember, hypothesis test always has a null hypothesis. It always has an alternative hypothesis. First thing we need to identify is, are we talking about means or proportions? Proportions, because we're talking about, percentage, right? Pass rates. Everything here is proportions, right? The null hypothesis is always going to be equal to. So previously the rates were 65%. We want to see if they have changed. So what should we set our null hypothesis to? Yeah, the way you would perform this test is you would set it up in a scenario where you say, okay, let's assume that the rates are exactly the same. And we'll assume that until we can otherwise prove or otherwise be convinced that they have what? Gone up, down, or changed? Well, it'd be cool to know if they went up. Of course, it would also be very nice to know if they went down. And in fact, that's the reason I phrased it like this. They just want to know if it's changed. And so this would be one of those scenarios where we may actually pick a not equal to alternative, right? Because we care both ways. If rates went up, great. If rates went down, I should probably know that. And so this would be a great example of when we might use not equal to. Does that make sense? All right. Cool. Okay. Now, let me see what I got next. Oh, here you go. So this one says that in 2017, yeah, I need to update my numbers. The average price per square foot paid for a house in Kennewick was $94.35 per square foot. You're going to randomly select 50 recent sales in the area and find their average price per foot because you think prices have gone up. And you want to see if you can prove that. You want to see if you can prove that prices have risen. So we could state this and frame it as a hypothesis test. First, we have to identify, are we talking about means or proportions? Means, right? Average, right? Average. So everything is in terms of mu here, and the null hypothesis is always equal to. And just like the last scenario, if you're trying to prove that things have changed, the best way to do that is assume they haven't until you can show that they have. So our null hypothesis should be that the mean is what? Yeah, we'll assume that the mean is still 94.35, but what we think we can show is what? Yeah, and so this would be an example where we would probably use a greater than alternative. Okay. So far, so good? Okay. So we have a null hypothesis or claim being made. We'll assume it's true until we can prove otherwise. But we're going to do our best to try to disprove it. All right, so this is actually, so a hypothesis test is sort of like a trial. Like if you're being in if you were convicted of, or not convicted, but accused of a crime or something. So in a court of law, supposedly, the way it's supposed to work, right, is that defendants are considered innocent until proven guilty. And so you can think of a trial as a hypothesis test where you walk in with a presumption or assumption where the claim or the null hypothesis is innocence, and then the alternative is guilty. And so, right, so the prosecutor is doing as much as possible to convince you to deny the claim and accept the alternative, right? And so the burden, supposedly, right, the burden is supposed to be on the prosecutor to provide enough evidence to you to convince you that this person is guilty, right? And if they can't do that, then you should just assume their innocence. And that's how a hypothesis test works. I'll take the claim at its word. I'm still going to do everything I can to disprove it, but if I don't see enough evidence to disprove it, then I just need to accept it. You know, I might go out and drive some Hondas and find that they're a little bit below 45 miles per gallon, but if I don't see enough to convince me that it's not true, then I just need to take their word for it. Okay. All right. So the thing is, though, is that with just like a trial or whatever, I mean, besides like a mistrial is an option, there's really only two possible choices. Okay. So if you're going to trial and you're on a jury, you really only have two choices, which are you can either declare the person innocent, which is the null hypothesis, or guilty, which is the alternative. And so basically, you can either reject the null hypothesis. That's one possibility. So you can reject the claim, or and it's kind of phrased. You can either reject the claim or you can fail to reject it. So I can either reject what you're saying, say I don't believe you, or I can fail to reject what you're saying and say, okay, as far as I can tell, you could be telling the truth. So if you reject the claim, you're going in favor of the alternative. If you fail to reject the claim, then it's kind of like accepting it, but it's not like you're never really endorsing the claim, even if you fail to reject it. But you're just saying it seems possible. So those are the only two possibilities. All right. Well, the problem with that though is if you are sitting on a jury and you decide someone's innocent or someone's guilty, does it actually change whether or not they committed the crime? It doesn't change whether they committed the crime. It's just what you think. But whether you convict them, that doesn't change what happened in the past. And so the problem is that you can make a mistake, right? And so we have errors, and the thing is that you can make two errors. There's two errors you can make. When, say, like if you're on a jury and someone's being tried for a crime, you can make two different mistakes, and what are the two different mistakes you can make? Yeah. You could convict them of a crime that they did not commit. That's bad. Or you could not convict them of a crime they actually committed. There's two ways to mess it up, right? And so this is the same thing with hypothesis testing. So I'll draw this little table here. Okay. So the idea is, let's say you can make one of two decisions, right? You can either reject the claim or you can fail to reject the claim. Okay, those are your only two choices. I can either convict them or not convict them. But that doesn't actually change the reality, because in reality, either they were telling the truth or they were not telling the truth, right? So you're going to make your most educated guess as you can about whether they're telling the truth or not. But in reality, you'll never know for sure, right? Unless you just have like bona fide truth that they're wrong. But that's rare. Okay. So the idea is some of these things are okay. Like, for example, if I reject the claim, so if I'm in column 1, so if I reject the claim when they were telling the truth, right? Or when they were lying, right? So reject the null when the null is false, right? So if I land in this box, that's a good choice, right? Because I rejected their claim and I should have, because their claim was not true. And so this right here, this would be a good choice. So I'll put a smiley face, right? That's like if you reject their innocence and it's good because they were lying about being innocent. I mean, it's not good because they still committed a crime, but it's good because you made the right choice. You convicted them of a crime they commit, right? Same with over here. If I fail to reject their claim and their claim was true, that's a good choice. They said they were innocent, I believed them, and they were. Okay, that's good. The problem is in the other two boxes. So if you reject their claim when their claim is actually true, this is what we call a type 1 error. So I'll reject what they said, but they were actually telling the truth. That's not great. Okay. But that's not the only way you can screw up. I could fail to reject their claim when they were actually lying. So I should have called them out as liars, but I didn't. And so if this is type 1, then this is probably, any guesses? Type 2. Yeah, that's type 2 error. So there's two types of errors in hypothesis testing. Just like there's two types of errors when you take someone to trial by jury. Okay. All right. Does that make sense? So essentially, not only are you never going to know about what's actually happening at the population level, but there's actually two ways you can mess up your decision. And neither of them are great, right? So, like if you talk about the court of law, right, this is just something to think about. It's an easy way to interpret these type 2 errors, right? In the court of law, the presumption is innocent until proven guilty. So, we talked about there's two types of errors. Well, which one of them is type 1 and which one's type 2? So, type 1 means you reject the claim when the claim was true. So, a type 1 error in this scenario would be what? You convict them of the crime when they weren't, right? So, the type 1 error would be that you convict an innocent person. And then the type 2 error would be what? Right. Mm-hmm. So you, exonerate, or you don't convict a guilty person, right? Okay, so which one's worse? Is type 2 worse? They both suck for different reasons, right? Which one is the greater sin?
I would have to say 1.
A lot of people say 1, at least, and that's how our justice system is supposed to be set up, right? A lot of people say type 1 is the greater sin. Convicting someone of a crime they didn't commit is worse than not convicting someone who did commit the crime. Now, obviously, there's very big consequences to a type 2 error, possibly, maybe.
Chances are type 2 they're going to fit again.
Yeah, like so. It's like now. Of course, if they're like a serial killer, it's like okay, yeah, they're gonna offend again. But then people are So I mean, it depends probably on the crime, So depending on the crime and the consequences. But generally, we say type 1 error. Now, type 1 is worse, and it actually matters because, and this is I'm kind of running out of time, but I'll just mention this. This is where we'll pick up tomorrow. But essentially, we actually can control one of these types, or sort of control both. But remember, when we talked about confidence intervals, I told you to think about your alpha level, right? Think of your alpha level as an error rate. And your alpha level is actually the probability of a type 1 error. So your alpha level is an error rate. In a hypothesis, when you frame something as a hypothesis test, though, that alpha level, what it controls is it controls your type 1 error rate. And so it doesn't control your type 2 error rate, though. It just controls your type 1. Now, if you really, something to think about, though, is that if you really, really don't want to commit type 1 errors, right? I really don't want to do this. Well, if I set up my justice system so that this is really, really hard to do, what's going to happen? This is going to happen more often. See, the trade-offs, they work against each other, right? If you're so concerned about convicting innocent people that you make it really, really hard to convict people, then what you're inevitably going to do is you're going to let guilty people off, right? And you're accepting that because you really don't want to do that. Whereas if you go the other way, if you say, hey, I really, really don't want to let innocent people go, so I'm going to lower my standards for convicting people, well, what are you going to do more often? You're going to do that more often. So the types of error, the two errors work against each other. Okay, so it's like if you want to drive one down, you're going to inevitably drive the other up, and vice versa. And so, of course, there is one way to drive one down and also drive the other down. Anyone want to guess? Yeah, you could just not have a justice system. Just anarchy, right? Just be whatever you want. But think about this in terms, like, how could I be more sure that I'm not making an error in a criminal case? Like, what could a prosecutor do in that case? More evidence, right? The only way that you can drive both of these down at the same time is to collect more evidence. In statistics, what that means is more samples. So you can do it. It's just, it comes at the cost of more samples. So anyways, we'll talk more about that tomorrow. Essentially, you set your alpha level in advance, and then you hope that your type 2 is not out of control. So.